coming in. I'm going to blame it on registration and registration being really, really busy right now. We've got a lot more people that we're expecting, so they'll be filling in. You'll have lots of neighbors. It's going to be fun today. My name is Scott Burnell, and I am the global lead for partner management and business development for the Ford Developer Program. Based on the name, obviously you can tell that this is their third annual conference that we've done here. And really the way that we look at things in the Ford Developer Program and the way that we look at connectivity in Ford is to embrace innovation. And that's really why we're here and why we invite all of our friends out here. We know that we can't do this alone. Nobody can really do this alone. That's why there are millions of developers around the world. We'd like to embrace those developers, and we'd like to find ways for them to show us innovation and to bring those great ideas to fruition and connect in the vehicle. You're going to hear from a lot of people today who are a lot smarter than me and are going to talk about things that I don't understand, but that's why you're here, is because you understand it. We're going to talk about AppLink, which is the Ford product, which is built on the SDL platform. So we'll be diving into SDL as an entire platform and how that can really benefit the industry, not just us here in the Blue Oval working, but all of the OEMs and also the developers. There's a lot of things that go on in the world where developers kind of are a second thought to the product that gets put out there. And we feel that it's pretty important to make sure that developers are embraced and developers get their voice and get their content out there. I'd like to say a special thank you to some of our friends at iHeartRadio who helped us out this year, and also the App Developers Alliance and the Michigan Telematics Association, the Mobile Telematics Association of Michigan. They were friends of ours who helped promote and are going to help fill this room here eventually. We've got a good show, some housewarming notes or some house cleaning notes. We do still have breakfast available in the back. If you haven't grabbed anything, please do. We'll obviously have some snacks available and some beverages available throughout the day. Restrooms, we can't make them any closer. They are right across the hall over there. We will be breaking for lunch at noon, or 12:30, excuse me. Lunch will be provided. We'll probably have it right in the back hallway again, so please join us for lunch. And once we have concluded at 6 o'clock this evening, we're actually going to have a cocktail reception, I believe in the room right next door to us over here. Have some hors d'oeuvres, have some cocktails, talk about all the really cool stuff that you just learned for the day. And then when we finish that, we invite you to stick around for our hackathon. That's where the rubber hits the road. That's where you take all the fun stuff that you've learned throughout the day, the things that I have no clue how to do, and then you make them into something really cool that can work into that thing that's really cool right there. The hackathon will start about 8:30. We'll be doing a master class, getting you guys started on an application, or kind of getting your application up and running if you've got it with you. And it's going to run until 9 a.m. tomorrow morning. We'll give you lots of Red Bull, we'll give you pizza, we'll give you all kinds of stuff to make you go throughout the night. And then once we're done at 9 o'clock in the morning, we'll be providing hackathon support on the CTIA show floor in the Ford exhibit. So there's going to be a special area just for the developers to come in, meet with the Ford dev team, and get hack support. And then on Friday, we want to see what you've got. We've got a stage set up there, and you'll be able to show off your application and compete for a number of different prizes. We've got some cash prizes this year, and we've also got the ability to win a trip to CES with us in 2017 in January and show off your application to the world. Show them what you've done and what you've integrated with AppLink and SDL. So again, I want to thank everybody for coming today. We are going to get started now, and I'd like to invite to the stage Mr. Dave Hatton, who is the manager for AppLink and SDL and emergency assistance for Ford Motor Company.
Good morning, everyone. And again, like Scott said, welcome. We're really, really excited to have you all here today. This event here is really about, we're calling it Make It Drivable. And we basically want to see what your innovation is, what you're going to bring to the table for Ford to see your creativity, your ideas come to life. We're here to teach you and to educate you, and we hope that you go away from this conference learning something new and exciting, and we hope to see for those of you who are participating in the hackathon, what you come up with. So it's really exciting for us to have you all here, and we really appreciate it. My name is Dave Patton, and mobile applications and emergency services. I think the mic's cutting out a little bit. Some of you may know Julius Marchwicki, formerly oversaw AppLink. I took it over at the beginning of this year. Julius is now our director for connected vehicle and services in China. And I have been involved in the connected vehicle and services space, working on emergency services and emergency assistance for the last 9 years. And when Julius left to take his assignment in China, I expanded and took on all of the AppLink and SDL-related products and other mobile application things within Ford. And it's really exciting for me to be here, my first hackathon and developer conference. So I'm excited to meet many of you and to see what you guys create and come up with. My background, I do have 22 experience. Yes? I'm going to swap out. You can turn that one off. I turned the other one off, so now I'm kind of wired up with 2 microphones. So make sure that there's no hot mics later, and they're both turned off, hopefully. So I have worked in telematics for 9 years, and I do have 22 related patents in the telematics field. A lot of those have to do with emergency services because that was my focus. But I did work with a lot of different connectivity projects over the years, some of them with vehicle health, some of them with even integrating the first, for Ford, the first smartwatch into a vehicle for command and control external to the vehicle. And I really love new technology, and I'm kind of like a first adopter on things. So when I got the opportunity to work with AppLink, I was so excited because I knew that it always meant new things, new apps, new integration, new opportunities to connect what the users of our vehicles are doing every day on their mobile devices into the vehicle and make it a much richer experience. So Henry Ford said in 1924 that he had a wholehearted belief that riding the people highway should be within the easy reach of people. And today, in 2016, Bill Ford says, we're a car and truck company, and we've redefined ourselves as a mobility company. We have to imagine a future not just as makers of cars, but as transportation providers. So Ford says the role of us as a company is to improve the lives of our customers, and that's what we're thinking about all the time, and it's true. It's going to take partnerships with big tech companies as well as startups. So we're looking for everyone to help and participate and help us to realize this vision. So following on that, our vision for connected vehicles and services is to open the connected vehicle highway for all mankind. So we think that this kind of embodies that new vision and directive from Bill Ford. So what are our customers looking for? 63% would like to operate a smartphone while using controls and steering wheel while driving. 57 would like to surf the internet or via a monitor in their car. 56 would like to have an in-car feature enabling the ability to read and direct and dictate emails to them while they're driving. And 51% said they would like to stream music in their car. We know many people are doing that today already. So how do we accomplish this? Our connected solutions have a broad scope. We span the built-in, the brought-in, and the beamed-in. And we have many examples of this at Ford. We think of our vehicle as a software platform. And today, the average high-end car has roughly 7 times the amount of code as a Boeing 787. And we know that it's just ever growing. So in building a platform, we can take and accommodate new features and new capabilities all the time. And we can expand it and open it up to all of you and see what creativity and the offerings that you bring to the vehicle. So here's the things that we offer. We have a built-in solution with Sync Connect. Sync Connect launched in 2017 on the Ford Escape. And this is the ability to have a connectivity to the cloud, have an application, our Ford Pass application, which is a major effort by our company to put all of our resources into one application that can use as your command and control center for your vehicle, connect to your billing accounts, also use it for mobility features like finding a parking location, and also new things that they have planned that you can use this application in coordination with your Ford vehicle to plan out your journey. That has a 4G LTE connected modem. It gives you great speeds. And we're building a platform there, an SDN, a global one, that we can connect our vehicles to the cloud. We also have the broadened solution. The broadened solution based on Ford Sync. Ford Sync, which is now in just about every model that we build around the world. We have nearly 15 million units in the marketplace. And this has been a phenomenal success for Ford. It was something that we introduced back in 2007, revolutionized the industry by bringing voice command control to the vehicle and building a platform that can be upgraded over time to add new features and services. Of course, some of those things we're going to talk about today, like Sync App Link, which has always been evolving. Also SDL, what that means, and the evolution of Sync App Link. And emergency services, which I'll touch a little bit on, just to give you some examples of that platform because I'm pretty passionate about it. And also we have traditional in solutions like SiriusXM with Travel Link. So you can find your movies, get your latest information on traffic. You can also look at sports scores and get information that's relevant to your daily drive. An interesting thing is happening amongst these things is that there is a kind of a cross kind of evolution across the built-in, brought-in, and beamed-in, and some of the applications and some that you might even be working on might someday span more than one ecosystem. An example of this is Ford Pass for us, which uses both AppLink and also uses, if you don't have an embedded modem in your car, you can. I think my mics might be going out. I might move to the podium if that's the case. I'll try it a little bit more. So you can also like SiriusXM, you have an application that we talked about earlier this year that's in development that also might bring extra content to the vehicle through an AppLink app where you can get pre-recorded programs. You can get your preferred channel that you might want designed for yourself that you might not be able to get from a beamed satellite directly from the cloud. So you can kind of mix these things together and start to use all of the platforms to your advantage. And I think we're going in that direction where we're going to have cross-platform solutions. So 911 Assist. This is one example of a broadened solution. I put this slide in there just because I don't think I can give a presentation without talking about it because I think I'm so passionate about it. Because this is one of those technologies that Bill Ford talked about that really helps to change the lives and improve the lives of our customers. 911 Assist uses your smartphone, your phone, when you're in a vehicle to notify 911 in case of an airbag with a deployment of an airbag or a significant rear collision. And we came up with this idea and we connected it basically to the existing infrastructure and took advantage of that today so we could offer it free of charge to our customers for the life of the vehicle. So if you purchase a vehicle with Sync, you had this type of protection and you never had the failure of the cost to resubscribe for any type of service to get the basics of contacting 911 in an emergency. So this is just one example of a broadened solution that really makes sense and really our customers appreciate, and it's been credited now with saving lives. And we do feel that it does, is one of those products that really does improve the lives of our customers. And of course, today we're here to talk about AppLink. It's the automotive industry's first mobile device connectivity solution. Right now, we have a global footprint for AppLink. It's in 6 million vehicles. So if you develop an application that comes out of the hackathon event here, it winds up getting published and out into the store. and you have a global reach potentially that you can reach with that application. So that takes your application and interfaces it with the vehicle. It allows the driver to have voice command control and steering wheel and interface, tactile feel, capacitive touch interface with your application without somebody having to pull out their phone out of their pocket, look at it, have a distraction while driving. So this is really important, and we believe that it can also, like 911 Assist, help prevent accident. It can help save lives by preventing an accident in the first place. So drivers perform the app commands that they're familiar with using either the interface on the HMI or using voice commands as well. So AppLink has started off, I believe, in a 2-line type of display and went to a small 4-inch display. And then as Sync grew up, it also evolved. And today's new Sync 3 system with capacitive touch offers a great experience for apps. And we've evolved the platform to match for AppLink as well. So apps have branded icons now that are integrated, well integrated into the vehicle display. It gives the feeling that the app is built into the vehicle. So your native application for Pandora or for Glimpse, when you get in the car and your phone connects over Bluetooth, when you go into the apps tray, it shows up like it's integrated right into the vehicle without you, or if you're an OEM, having to have another store that you have to have your customers go and download and have a unique application design specifically for your vehicle. So that's really one of the great benefits of AppLink. So various screen templates are there and offer up multiple fields for developers to send data and create a very familiar interface and experience that you can recreate in the vehicle while someone is driving. So you can choose from these dozens of layouts, and they help you as a developer integrate into the vehicle and along the driver distraction type of guidelines as well. It helps you prevent some of the things where maybe you have too many screen flows or too many icons or too small a text. Things that are, as NHTSA is giving out new guidelines in the future, would be very complicated for any common app developer to understand or try to figure out all the different rules. How many glances can you have? How many clicks can I make? Those type of things are going to be taken care of for you so that when you design, you can just easily plug into the templates, choose your icons, set up the application with voice commands in a very easy interface and a very easy way for you to develop. So we offer the large graphic fields, like I was saying. You can show map location, the weather, radar, relevant content that you can bring to the display, to Sync 3. So it's a great and exciting platform, and that's something that we have launching globally. So along with that today, we do have now over 100 applications that are taking advantage of AppLink. And maybe for some of you that are participating in the hackathon, maybe yours will be one of these we can add to the list. So that would be a great, exciting outcome for you participating this week in this event. In order to help support AppLink, we created a developer program. And the developer program has direct outreach to developers where you can sign up, you can get an app ID so that you have a unique application ID, and then you can start participating and get on the development of your application. You can get one-on-one support. You can look at all the documentations and the guides that are in there to help you understand how do you integrate with Ford's vehicles and the different generations of Sync as well, and how do you exercise maybe those correct voice commands and what vehicle data do I have access to. All of that you can find in Ford's developer program. If you haven't signed up, go to developer.ford.com and please sign up today, and you can participate in that community there. One of the other things that we do in the developer community space is we supply tools for you to help test and develop applications. And we're really excited about something we just announced back in July, which is the Sync 3 emulator tool. And the Sync 3 emulator tool is something that really helps you develop your application and get it to market faster. It's a tool that allows you to emulate what's going on in Sync 3 quickly without having a test development kit or even a vehicle. So you can test your application, compile it, and see how it's running, make tweaks, modify it, and basically get a turnaround much faster on the application itself. So we're pretty excited about this new tool. And today, this week during the event, and even later today, some of you will get that loaded on your computer. We do it on thumb drives for those of you who are participating in the hackathon, so you yourselves can use the emulator tool and see all the great power it provides, like GPS information, vehicle data that you can simulate and see how that responds with your application. Of course, with all this great work that we've done in AppLink, we thought that we could really benefit from putting it in the open source community and growing it, allowing others to participate in the development and the future development of it. So what we did was we put it into GitHub, and we created Smart Device Link. And Smart Device Link is kind of the white-labeled version of AppLink. And now AppLink follows Smart Device Link for the new code that's developed and that's put into SDL, then will get adopted into AppLink. So we think that this is a huge advantage for the automotive industry. And we are also really pleased to say that Toyota now has said that they will also adopt this technology. And we have other partners like QNX and UI Evolution that also are utilizing and using SDL. So SDL now is also being investigated by Citroën, Honda, Subaru, Mazda, other OEMs, so that they can get the benefit that we have at Ford and AppLink Apps, that we can grow the platform together as a community, and that app developers, when you create an application, you not only have Ford vehicles now that it could potentially work in, but you could also have Toyota and other OEMs as well. So this creates greater volume and greater consistency across the industry for the integrations of applications. So a lot of the benefits of the SDL and automotive collaboration are retaining the OEM branding, having that open source community I talked about where people can donate code and improvements into the GitHub, utilizing new APIs, new applications that are extending the platform, having a product roadmap that we can come together and agree on that would benefit the entire automotive industry as a whole, and data stewardship. Right now we have Livio, that's the project maintainer for for SDL, and they basically are taking inputs not only from Ford but from Toyota as well, and we collaborate together as an industry to say, where is this product going? What do you think is the next thing that we should be working on to be competitive? And this type of collaboration, as it continues and as it grows, is only going to make the SDL product stronger and better, and we're all going to benefit from it. And the app developers are going to benefit from it as well. Developers across the spectrum will benefit from it. So with the announcement of Smart Device Link, we've also recently launched SDL, smartdevicelink.com. And this is where you can go and get similar information to the developer.ford program, but it's information about creating applications that not only work on Ford vehicles, but opening up the door, basically, for all the other OEMs as well. So this will be your portal of entry, and you could design something for SDL that then could get tailored for a HMI experience in a Toyota vehicle or tailored for an HMI experience in a Ford vehicle. So on that website, you'll find all sorts of types of resources and guides as well, and you can also interact with the community there. So one of the things that we're working on now that's in SDL is mobile navigation solutions. So we're really excited about this. We showed off some examples at Mobile World Congress. We have some people I've heard that are going to be working on some mobile navigation solutions today with this code or during the hackathon. Here, what's showing on the screen is our internal version, we call it Antelope, that we've developed to test out and learn, basically, as we integrate with mobile navigation so that we can use that with outside suppliers and partners. So here you have, if you were to get in a Ford vehicle, you could plug in and you could select whether you want to use your embedded navigation if you have it or your preferred mobile navigation. Maybe you don't have embedded navigation at all, and you have a mobile navigation application on your phone. When you get in and you plug into your vehicle, and I'm talking about plug-in, it's a projection type of experience, so right now you have to plug in for this, as opposed to just Bluetooth connectivity to get the higher bandwidth. But when you connect to the vehicle itself, you get this mobile navigation experience from your mobile nav application on your phone, and you may not have navigation in your vehicle at all. And this is great for markets where perhaps maybe we can't, as an OEM, even offer an embedded OEM solution because we don't have maps available in certain markets. But there is a mobile navigation provider and solution that works really well that we can integrate into the vehicle. So we're really excited about this product, and we can't wait to get something out there in the marketplace that takes advantage of the mobile navigation. Also, another type of new solution coming, which is also already integrated, is Send a Car. This already works on a Glimpse application where you can have maybe a friend send you a notification as to where they're at, and you want to go meet them. And now you can, if you have embedded navigation, send that destination very easily with a touch of a button from the Glimpse AppLink app, send that location to your embedded navigation, and then navigate directly to wherever your friend is. And this is just taking applications and finding easier ways to integrate them into the in-vehicle experience. So we love basically new partners and new opportunity, new ideas, new ways to development. We love innovation. We love entrepreneurs. And I wanted to kind of demonstrate to you today that we're serious about this. And we have a number of hackathons. I'm going to share with you some of those from around the world. We've brought our best engineers and developers from Dearborn and from Palo Alto here today to help you learn about AppLink and SDL, about how you can take your application and modify it to be the best user experience inside a vehicle, to help reach new markets perhaps with your application. While somebody is sitting in traffic for an hour or two a day, they have access in a safe way to interface with your idea or your application. So a few examples to support that. In the past year, we've done similar events to this, developer and hackathon events in Dublin, and in Mexico, in Tel Aviv. Also, we have long-running challenges that are several months long. One of them is the Henry Ford Health App Challenge that concluded in June. One that just wrapped up recently in July was the Ford DJI Drone Challenge. And those are basically a little bit longer, but then they have a judging phase. And then, of course, today, and what's really exciting about today is we have 2 developer conferences going on simultaneously, one here in Las Vegas and one in Berlin with AppLink focused on mobility and that vision that Bill Ford has, and just trying to see what type of mobility solutions for inside and maybe even outside the vehicle that our partners might come up with. So we're really excited to have 2 of these running simultaneously, and by the end of the week, we'll have 2 new winners as well for Ford Hackathons. So speaking of winners, I wanted to share with you some of the creativity of some of these hackathons and run through with you a list of the applications that folks came up with. A lot of the new capabilities of AppLink give you information about the vehicle that you can't get from any other type of experience, plug-in experience. You can get vehicle data like the fuel level. You can get your GPS information, precise GPS information with dead reckoning. You can also get whether your door is open or ajar, and all these type of signals that are coming in, your fuel level, if it's empty, those type of warning signs, directional signals, things like that. All these things that are coming into the vehicle, we've given access to for AppLink so that you can utilize this vehicle information and this data to enhance and perhaps make some really creative driving experience applications. So one of them that we had from a winner from the Ford Mexico Hackathon recently was Fuel Check. And here was the problem that we call it don't get ripped off. The problem is that fuel stations in Mexico, you dispense fuel into your vehicle, and you're actually getting less fuel than what's shown at the pump. So what AppLink does is it reads, with this application, it reads your level before and reads your level after you fill up, and compares to make sure that you get the right amount of fuel. And if it's not consistent, it quickly and easily gives you the link to actually notify the authorities in the national database that there's a problem at this fuel station so that hopefully it can get corrected. And this will hopefully reinforce over time some better behavior by those that are dispensing the fuel. So we thought that was a great idea and would really benefit customers in Mexico. The next one here is Dublin Hackathon, where we call it, this one is called Drive More Efficiently. So it monitors whether or not you're over or under revving the engine, so you get engine performance data. And if you're using the best use of the torque of the engine as well. This is the type of extra data that we're getting in the enhanced AppLink today. And then it provides verbal and visual feedback to encourage the driver to have better driving behaviors and able to conserve fuel, and warns them about how they can improve their fuel consumption. Another winner here is, another innovation is monitoring drivers for signs of drowsiness. So at the signs of driver drowsiness, the app performs an escalating level of alerts to make the driver aware of his or her conditions. It includes chimes, changing the radio volume, even an automated SMS message and phone calls to a driver's contact list so that maybe someone can give you a call if you're starting to fall asleep and you want to wake you up. So this is just using vehicle performance information, vehicle information that we're providing now to the apps and enhancing a great application to make the lives better and potentially, again, avoid a collision or an accident. Here, the winner of the Health App Challenge. This one took the 911 Assist product that I was telling you about earlier, the service, and enhanced it by adding personalized information to the information that got sent up to the call taker when they received the call. So this was really interesting because they took vehicle data as well as the patient's information, and today we put vehicle data up via voice to the call taker, where in this experiment, in this challenge, winner, they took data from the vehicle and packaged it together and took one of the major 12 providers of health information, married it together, and sent a message to the first responder, to the dispatcher, basically, who opened it, and then could pass it along to the first responder about some health conditions of the people in the vehicle and also the health status of the vehicle itself. So this was a really interesting one, and I was really excited to see this one come about, obviously, with my interest in emergency services. And that, of course, used AppLink to get that data to the app. And most recently, we had a winner from Team Atoro, which is the DJI drone winner challenge, where they landed a scout drone on a moving vehicle. So this is, say you have an emergency situation, maybe there's an earthquake or there's fires, you go out to monitor the area, you leave with your F-150 with your drone on the back, it takes off and can monitor from a high point of view what's going on, and then returns to a moving vehicle and lands on the back bed. So this was done fully autonomous for this experiment, and we thought it was a really cool application and integration into the vehicle where you could utilize the AppLink application just to do a simple takeoff, command, and land control. We did have some areas where it would fly off to use QR codes and the locations that we wanted it to scout to come back. But you could also have somebody who's flying the drone, maybe with a virtual reality helmet on or something like that, to kind of see what's going on, and then also have an automated auto landing on a moving vehicle when you're driving. So we thought this was a really cool interface for DJI and Ford, and with a, I would say, a very innovative solution to something that we think could really be useful in the near future. So, with all that being said, what will you guys bring? What experience will you build? What new innovation will you bring about? We're really excited to see for those of you who are participating in the hackathon this week. And you don't necessarily even have to be a winner to actually get the benefits. We've had second and third place folks who have designed experiments in the hackathon that actually became real applications. One of them is actually launching this week. And that's the second place winner from our Dublin hackathon. We were really impressed with them. We made some more press about them at the Mobile World Congress. And what they basically do is rent out your trunk. So you have an application where maybe you're driving, and this is in England, maybe from London to Leeds, and you can actually make some money on the way by delivering a package. So you can put something in your trunk, you can carry something, you tell them what type in the application, what type of vehicle you have, how large it is, what size of package you can accommodate, and then you can get paid for moving something for somebody. And the application basically interfaces to the vehicle and tells you when you pick up and when you drop off, and goes back to the website, I guess, to report the status of your route. So it's a really interesting success story, and it's launching this week, and we can't wait to see how they do. So perhaps the application that you develop will be one of these that launches in the store soon, and we can be talking about you next. So I would just like to say thank you again for participating. There's a lot of great material that we're going to share with you that you can learn the basics about AppLink and SDL. I have the engineers and developers here to help and assist you in your education. We're here to help and assist you if you're participating in the hackathon, working all night to make sure that you understand the code, how to interface easily with the vehicle. And on Friday, we can't wait to see at the judging contest what you guys come up with. It's going to be really exciting. So now I'm going to pass it off to Timur. He's over here. Timur Politanelli is going to come and share with us some of the AppLink development basics.
Thanks.
Thanks, Timur.
Just going to see your clicker. Hi, everybody. Also, welcome to the Ford Developer Conference from my side. My name is Timo Pulatanli. I'm the supervisor for AppLink Partner Development. So I work together with Scott. Scott is on the business side, and I make sure that everything on the technical side goes well. So as you can see, I'm wearing the mechanic shirt. So this will be not an overview or a business talk. This will be more nitty-gritty on how AppLink works, fundamentals of AppLink, how do you actually enable your app to work with the car, and what do you need to do that. So let's get started. We have a little agenda. We're going to talk about the concept of AppLink. So first of all, it's really important to understand what AppLink is, what it does, and why we develop it. Talk a little bit about the software overview. I thought we had it worked out with the mic. So talk a little bit about the software overview and make sure you understand what is important for your app and how you integrate AppLink into your app. We're going to talk about remote procedure calls. I'm going to get into that, why it's called and what it's doing at this point in time. We're going to talk about communications flow. So how does your app actually communicate with the car? What data goes back and forth? And what RPCs, what procedure calls do you use to communicate with the car? How does Ford make sure your app does what it should do? So what is policies? How does an OEM make sure that the app does not do anything that's distracting the driver from driving? And I'm going to give you a little bit overview about additional resources. What do you need? Where to get started? And what internet pages are maybe the most informative ones? So first of all, what is AppLink? Why do we have AppLink? What is the idea of AppLink? As Dave said, most importantly, we have to make sure that a driver is focusing on driving, hands on the steering wheel, eyes on the road, while they're in their car. So people still want to use their apps. People still want to be connected to their digital lifestyle while they're driving. So how do we take something from an interface like that? So this is Spotify on iOS. How do we take that from an interface like that, maybe an interface like that on a 3-inch system in the car, or an interface like this on an 8-inch system in the car, and make sure that the buttons are bigger, that the text is bigger, that there's not as much distraction for the driver? And how do we make sure that he can use voice recognition of the car that he's used to using while also to connect to his cars? Do we switch? All right. This is a good place to switch. Look at these. You can find a lot of elements that are in the iOS app, also in the on car screens. Sure. Oh, it's already on. Ready to go? All right. So how do we bring an interface from the app to the car? How do we make sure that people can use their apps safely while driving? This is what AppLink is all about. And so we decided it's not a good idea to put an app into the car. So nobody wants to download an app to their car because nobody wants to go and download an app to their fridge, download an app to their stove, download an app to their car, and then after you've done downloading all these things, you've done with your driving. So there's really no time and no interest in updating your car all the time, downloading stuff to your car all the time. So why not use the apps that you already have on your phone that are always up to date with all your data in and connect them to the car and use the car as an extended user interface of your app. So all the logic in AppLink stays on the phone. All the logic is handled on the phone, all the connectivity back to your cloud services or whatever backend you have stay on the phone. And the car is really just an extended user interface. So you use the screen of the car, you use the buttons of the car as an input, you use the voice recognition of the car for your interaction with the driver, but you don't upload any logic or you don't upload any big data items to the car. Everything is handled on the phone. This has multiple benefits. Probably the biggest one is you get in the car, you're ready to go. So you don't have to update your car. Let's say you get a rental Ford Mustang with Sync 3. You don't actually have to download your private apps to this car. All your apps are on your phone. You plug in your phone. All the apps come up. All the data is there. All your favorite settings are there. Also, if you share a car with your family, with your wife, with your kids, all your personal apps are there. You don't have to switch profiles or re-download stuff. When you get in the car, your phone is there, and you will automatically have all your apps at your fingertips. Obviously, that brings the other big benefit that there's nobody who actually leaves their phone at home nowadays. So you will never be in a situation that you don't have your apps with you because people rather turn around and go back home and pick up their phone than having a day without their most personal device. So this is the concept of AppLink, and this is why we do it. And so we, as Dave said, we started in 2011. So we have quite a history with AppLink. We started on this kind of two-line display, what we call Sync 1. This was a North America only device. And you can see two-line display, non-touch system, no vehicle data, no graphics support, no soft button support. What you can see on the screenshot also is that AppLink is not a video streaming solution. So AppLink does not allow app developers, other than navigation developers in the future, to stream the UI. The idea behind that is that creating an automotive UI is very complicated. So if you're an app developer and you have maybe 10, 15, 20 employees, you have nobody that works in automotive. You have nobody that actually understands driver distraction rules and guidelines in the US or all around the world. So creating an app interface that is driver distraction certified and that can actually be used while driving is very, very complicated. And we have a couple of friends that you can ask how complicated it is. So we decided to go with templates. So for an app developer, it's much easier to say, OK, I have 2 lines of text I can fill. So I can give an artist and a title to the car, and the car will display it however it wants. The other benefit of this kind of templated approach is that as an OEM, we as Ford can design our screens however we want. In this case, you see our really small and pretty old by now system from 2011 that was able to show AppLink apps. Now, the next one has a very similar interface, but it has added soft buttons. We added a couple of features to it, and I took the wording there and I said no template support, which is a little bit misleading. It's still a template system, but it only does support 1 template per app. So you're going to see what we changed later in newer revisions of the Sync system with the different templates that apps can now choose from. And they gave you a sneak preview of that. So Sync 1.1 added soft button support. So now apps can actually design their own buttons and put them on the screen. It added basic vehicle data. So Sync 1.1 was the first version that actually enabled apps to get data from the car, like your RPM and like your current speed and stuff like that. And we launched Sync 1.1 globally. So Sync 1.1 was the first version of Sync that relaunched globally all across the world. And it has some different names across the globe. So I just called it Sync 1.1 here, but it's, for example, called Sync with Emergency Assistance and AppLink in Europe, and has a different name in the US and different name in Asia Pacific. So we moved from Sync 1.1 and moved into our touch systems. So you can see Sync 3, which is our latest revision of Sync, and we have a 4-line display, we have touch system, so it's basically moved away from being non-touch with hard button only to being a touch system. But for the app, there's no difference. The app doesn't even know if it's connected to a touch system or a non-touch system. So it's not important for it if the input comes through a touch screen or if it comes through hard buttons or maybe through a rotary push button that other OEMs like to use. So this in with graphic support first time, so apps can upload their screen art or your location or your context picture, stuff like that. We still have soft button support, and now we have template support, which means that apps can choose from up to 17 different templates and choose a template that is most suitable for their use case. With Sync 3, you can also see that the same app that can connect to Sync 1, Sync 1.1, and Sync 3 does not have to have any changes in their code base. They can just work with all 3 different items. See Sync 3 as a template that is obviously a Ford infotainment system. But the biggest benefit maybe of the template system is that as we go and we open sourced AppLink, called it Smart Device Link, other OEMs have the possibility to use their own templates with their own style and their own graphical elements. So the same app can connect to a Ford Sync 3 system that can also connect, for example, to a Toyota system in the future that will probably not look like the Sync 3 system, I assume. So these are the 3 products we have on the market from the Ford side that support AppLink at the moment. And obviously, Sync 3, we rolled this out this year globally, started in 2015 in North America. This is a very important sentence to keep in mind. So it's a little bit confusing. What we call AppLink, what we launched in 2011, it's our implementation of the open source technology Smart Device Link. So whenever you see Smart Device Link, you can think of it as the technology that powers AppLink. It's what is inside of your Sync system that establishes the connection, that gets all the commands, and does all the interaction with the app. And then Smart Device Link communicates with your HMI and with the OEM's HMI and puts everything on screen and stuff like that. So really, when I talk about AppLink, basically everything is true for Smart Device Link as well. Now I have a little mouse. Oh, it's gone. So the concept. That's the next step. In this slide, it's pretty crowded, but it gives you a software architecture overview about what SDL is and how SDL works. So this is the open source version SDL that I'm talking about now. And on the left side, you can see the mobile device. So the left side represents the smartphone, be it an Android or an iOS smartphone. And the box that is furthest to the left that says your app is basically the code of the mobile app. It is your music player, or it's your connection to your Pinterest app or whatever app you're using. Integrating into the app is the Smart Device Link library. So this is a part that you can find on github.com/smartdevicelink. It is the Smart Device Link library. We also call it a proxy sometimes. So if you hear that, it's synonymous to the SDL library. And the SDL library will actually enable your app to communicate with the car. So it handles all the communication back and forth, keeps it alive, and it connects you to the car through 3 different channels at the moment. So again, I just want to emphasize, I'm talking about Smart Device Link here. So this is what Smart Device Link can do. Smart Device Link can use USB, Bluetooth, Wi-Fi, or any other TCP-based TCP/IP-based connection to connect to a head unit. This is not what Ford has currently implemented on their cars, but this is what Smart Device Link can do in general. So you will see if you develop later your app on the hackathon, you can use Wi-Fi to connect to your emulator. You don't have to use Bluetooth or USB. Now, generally, Smart Device Link is absolutely transport layer agnostic. We don't care. It can be Wi-Fi, Bluetooth, USB, whatever channel you want to open up, we can do that. It's not important for us how the data goes cars and the phone. When we move into the infotainment system on the right side, obviously this is the part that is in the head unit. So what we call SDL Core here is really the smart device link technology. So you can find SDL Core on GitHub again, github.com/devicelink. You have the package that's SDL Core that gets dropped into your infotainment system. So if you think about Sync 3, we have SDL Core in there. It's a program that's running on the head unit that handles all the connection to the app. Now this program that's running on the head unit has all the different connections to all your in and output systems. So it connects to your display, it connects to your voice recognition, it connects to your text-to-speech engine, it connects to your heart buttons, it connects to your vehicle data. All these different connections are handled by SDL Core, and then SDL Core makes sure that the data gets out to the app. So this is what SDL can do, but this is not what every OEM will implement. Not every OEM will have Wi-Fi in their car. Not every OEM will support USB for Android, for example. So little note on what's important for the app developer. And now you can see what we do on Sync 1, 1.1, and 3 at the moment. So we don't have Wi-Fi. Just to be clear, there's no Wi-Fi in the car at the moment that connects to your app. So what we utilize is USB for iOS. So if you have an iOS device, you plug it in via USB and it starts communicating. And for Android, we use Bluetooth. So these are the two different technologies we're using in the Sync systems. So if you see a TDK like this or the Mustang with Sync 3, you're going to use USB for iOS, Android for Bluetooth. But again, this is just the implementation of Ford. So if you come across a Toyota vehicle, for example, it could be different. And a third OEM that implements it could be all via Wi-Fi, for example, or any other technology. So remote procedure calls. That is the next topic. And we're going to talk about how does an app actually communicate with the car. So what goes back and forth. So basically, what we're doing here is I'm going to show you a flow chart that, or a sequence diagram that will actually give you the calls that go back and forth. So when your app connects to the car, the first thing it does is actually tell the car who it is. And it does that through a request. So we have three different kinds of remote procedure calls. We have requests. So everything that goes from the mobile device to the car is called a request. Everything that goes from the head unit to the mobile device, it's called a response. So basically, whenever you send a request, you will receive a response. So let's say you say, hey, please show this text on the screen. The response will hopefully be success to that. When you ask the car to please let the driver choose one item out of a list, then the response will include the item that the customer or the driver chose. And we have a third kind of RPCs, which are called notifications. So sometimes stuff on the head unit happens and your app has to be aware of it. So let's say the driver has your app in focus, but then switches to the navigation screen. So he can't really see your screen anymore. Now, of course, if he can't see your screen, you don't want to put some important notification up on the screen. So what we do is we use notifications to inform apps about what is happening on the car side. So, for example, is the car moving? Should you show the lock screen? Or what is the status of the screen of the infotainment system? Is your app in focus, or is your app in the background, and stuff like that. So also, as you will see later, your apps will be able to populate a menu that has different commands. So we use notifications too. If a driver selects one of your commands, you will get a notification that will let you know, hey, the driver chose command ID 14. Now please do something with that. Because we, as the OEM, don't have any logic in the car, we just tell you the driver chose command ID 14, and now you have the logic in your app to handle that command ID. So going through requests. One very important item on requests is every request has a correlation ID at this point in time. So when you basically send out a request, you give it a unique ID. when you get a response, it will include the unique ID. So you always know what response belongs to which request. You see that their correlation ID is in the arguments on the top part, and these four items are always in a response. So you get the correlation ID, you get a success boolean 0 or 1, you get a result code, and you get an info string. If something goes wrong, we try to inform the app what went wrong. Now this is the generic response information, but responses can include more data items. As I said earlier, when you ask the infotainment system to for the driver to select an item from a list, the response of that request will include the item the user chose. So there can be more interesting stuff in the responses, and generally, whenever you want to get something from the car in your request, it will be included in the response. So for example, if you say, hey, please give me the RPM of the car, the current revolutions per minute, then the response to that request will include that information. So I'm going to go through the most important requests that we have in our system at this point in time. So the first thing you want to do is you want to let the app know, you want to let the head unit know what your app is, what the name of your app is, what is the app ID, what languages do you currently speak, and stuff like that. So register app interface is the first request that an app will send always. So the app sends this to the head unit, so the head unit can verify the ID of the app, and the head unit can start showing the app in the car. Has the name and has more information like languages. Second important request is a put file. So put file does what its name suggests. It puts a file onto the infotainment system. So generally, it's mostly used to upload images to the infotainment system. So let's say you have a music player and you want to show some artwork. You use put file to upload the image to the car, and then you use the image in another RPC, in another request to show it on the screen. Put file is also used to set the app icon. So you saw on Sync 3, you can not only have your name on the screen, but you also have your app icon on the screen. So what you do is you upload it via put file, and then you set it as your app icon, which is the next request that's up here. So set app icon then basically uses the image file that you uploaded before via put file and sets it as an app icon. As soon as you set the app icon, your app will, the infotainment system will show the icon of your app on top of your name. We have add command, which is a very important request. So add command basically populates a list of menu items that is always shown in the system. So when you have an app and you see a screen and you have your title and your artist and your cover art, there will be a menu button on the top right in Sync 3. And behind that menu button, there's one item always, which is exit your app. That will always be there, so the driver can exit your app. But when you want to add additional commands to it, you use add command. So for example, in the Spotify case or a music player case in general, the add command is used to put a menu item in there that says choose playlist, choose artist, choose album, and stuff like that. So you use add commands. All these add commands also include VR items, voice recognition items. So the information, how you want to have an app invoked by voice recognition is also an add command. You can put in up to 100 synonyms in there. So it's not only choose playlist, it's also get me a playlist, I want to play a playlist, another playlist, or any other of the 100 synonyms you can think of in your app. Usually apps have like 4 or 5 synonyms, maybe up to 10. We give the option for 100, but it's kind of hard to think of 100 different types of choose playlist. And then I go a little bit deeper into what they do. And I was talking about register app interface, and you can see all the different RPCs, all the different arguments that go in there here. So you have app name, which gives the app name of your app, which will be on the screen. And then there's TTS name. So the app also has a text-to-speech name. There's one thing with voice recognition engines that everybody that's from the automotive industry knows is that they're really bad at pronouncing stuff that is not in their native language. So I always give the example of Spotify in Germany. Now, when people talk about Spotify in Germany, and as you can tell from my accent, I'm German. So when people talk about Spotify in Germany, they say Spotify. That's just they pronounce it in a way that an English speaker would pronounce it. Now, if our text-to-speech engine says Spotify in Germany, it says Spotify. And that is just because our text-to-speech engine thinks it's a German word. And pronunciation of the characters one by one after each other is Spotify in German. So obviously, when you have an app name, you don't want it to read some weird type of name so that the TTS engine speaks it correctly. But you also don't want the TTS engine to speak Spotify. So we split these two arguments. So you have an app name, which you can write in the English writing, which is Spotify. And then you have a TTS name, which you can either use phonemes for, or you can do a little bit of trickery and try to find a character combination that actually reads Spotify in German as if it would be pronounced by an English speaker. So in this case, it starts with a Z, and then it's an SCH or something. So it's a really different string than Spotify. But we tweaked it in a way that our text-to-speech engine says Spotify, and also, more importantly, understands Spotify. Because that is the case here, right? People want to be able to just press the push-to-talk button, say Spotify, and have their app on the screen. And that only works if we differentiate between app name and TTS name. So TTS name, VR synonyms, usually the same string. The one thing we added is the TTS name can only be one string, because our TTS has to be able to say what your app name is. But the VR synonyms can be an array. So you can actually have different VR synonyms for your app. So if you want to use maybe different pronunciations for your app, or maybe your app has two different names sometimes, it's not really clear what the user will choose, you can have an array of names for VR synonyms. Fourthly, we have is media application. Currently, AppLink has two major categories of apps. It's either a media app or it's a non-media app. So it's pretty straightforward. A media app plays music. So if your app has music content or any audio content generally, you would like to declare it as a media application. Now, what this does on the car is when I start your app and it's a media app, it will actually mute the audio. So let's say you were listening to radio before, you start Spotify, the radio will be muted, Spotify will start playing. Now, if you declare your app as a non-media app, so is media application as false, then the radio will keep on playing. So your app will start, but the radio will keep on playing in the background, the USB, music, or whatever. Even another app will keep on playing in the background. So you can listen to Spotify in the background, but start a non-media app and use that, and your Spotify will keep on playing in the background. Now, this is very handy for apps like Glimpse, or sports apps, or any other informational apps that don't have media content, because you don't want to be interrupted when you listen to the radio. We have language desired, which tells the head unit what language the app currently speaks. So in the US, it's pretty standard English, Spanish, French. In Europe, it gets way more messy with languages. It's a very hard problem for OEMs. And we decided to go in that way that the app basically lets the head unit know what language it speaks, and then the head unit will let the app know which language it speaks. So if these languages mismatch, so let's say I'm a German speaker, but my phone is set to English, my car is set to German, the app will connect, will let the head unit know that it's in English. The head unit will say, hey, sorry, I'm in German. Now, the app can switch to a different language and can say, hey, okay, I switch my database to German. Now, if the app does not have German content, we, OEM, will let the driver know that maybe the voice recognition and the TTS functionality will be degraded, because obviously, as I said before, if I feed an English string into a German TTS engine, it will sound pretty funny. And you will probably not be able to understand it. And the voice recognition the other way around, neither. So only if the apps and if the app and the head unit has the same language, it will be a really good experience. If they mismatch, we let the driver know that the app doesn't speak the language that sync is currently set to. And then we have an app ID. We talked about app ID, where your app has a unique ID, and we use that to handle all your policies, and I will talk about policies a little bit later, and identify your app uniquely in our backend. So the response, you will get response back, and this response has tons of items, and I will let you guys go through the documentation yourself and look at all these different items, but most importantly, 3 different things here. So you get a language back, as I said before. So it will tell you what language the head unit is set to. You will also get display capabilities and button capabilities and a lot of other capabilities. So in the best case scenario, your app is able to dynamically connect to a wide range of different head units. Now, some of these head units may not have, for example, a skip left button. Maybe there's just no skip left button on this head unit. Or maybe it doesn't have a play pause button or something like that. So this button capabilities structure tell you what the car can do. So the app can react to it and enable or disable features even if there is some features, for example, send location or vehicle data that your app necessarily needs. It can disable functionality if it's connected to a car that can't do it. There are so many different cars on the road, and the variety of functionality of these cars is so big that we can't always guarantee that something will work on every car. Outputs. So now you're registered, your app is in the car, the user started it, and now you can actually go and start interacting with the user. Now, most importantly for everybody, every AppLink app, it's the most frequently called RPC, it's called show, and what it does, it will populate the template with information. So if you guys want to show an artist on screen, if you want to show the weather on screen, if you want to show your current location on screen, all of that is done through show. Show includes the different lines of the templates, and show includes the soft buttons and all the graphics on the screen. So show will be your biggest friend when you work with AppLink and use it all the time. We have speak. Show is text that's on the screen. Speak is stuff that gets spoken by the onboard TTS engine. So one of the big advantages of solutions like smart devicing and AppLink is that your app doesn't have to have a TTS engine. Your app doesn't have to have a VR engine if you want to use it in the car. You can use the stuff that's already in the car. So Speak will allow your app to use the text-to-speech engine that is in the car to speak a sentence to the driver. Now, again, you have to watch out for languages. So only if your languages match, Speak is really good. If your languages mismatch, it's not a really good idea to feed a string of a different language into the Speak RPC. But generally, it's the best way to inform a driver about anything that's happening. So when something happening in your app and you want to inform the driver, use a Speak so that he can keep his eyes on the road and hands on the steering wheel and is not distracted. We have an alert. This is a little bit more intrusive to the driver. So an alert will actually bring a pop-up up on screen. So the alert will, when you put in an alert, you will be able to define a couple of lines of text. You will define a speak that goes with it. So you can have a text that is spoken by the TTS engine while the pop-up is on screen. And so if something important happens, so for example, I always like to use one of our European apps, which is called Go Live Score. So they give you live scoring information on something that we call football, which you guys call soccer. And when you drive around and your favorite team scores a goal, and again, because it's your favorite app, you have all your favorites set on your phone already. So the app connects when you drive around, and your favorite team scores a goal, you will get an alert with the current score, and you get a voice information via the Speak RPC that basically informs you about the new score. So this is for stuff that happens when you don't interact with the app right away. Alerts can be sent from the background. So we do have special permissions for apps, so your app doesn't have to be started up front. So this soccer app, the scoring app, if it connects, you don't have to start it. So it just sits in the background, waiting for a game to start, waiting for a score to happen. And as soon as somebody scores, it will show a pop-up, even if you're listening to radio or to USB or to any other functionality in your car. Now, this is something that an OEM has to allow. Not every app is able to do that. We don't want a Spotify, or we don't want Pandora to just bring you advertisement from the background or any other pop-ups from the background. So this is something where we talk with the app developers, and app developers request it from us. And if they have a compelling use case to use an alert from the background, we will allow that to happen. But again, this is all about driver distraction and about safe driving, so we don't just randomly allow that to all of these apps. Side note, if you want to do that at a hackathon, it's fine with us, usually. So Squirrel message. This is an output that we use for long text. So let's say you want to inform your customer of something that has 200, 300 characters and is a pretty big information, then you can use a scrollable message. It will bring basically up a view of your message on the screen. But this, again, is driver distraction critical. So in the US, we don't show this message while driving. So if your app invokes this RPC while the car is in motion, while the driver is driving, he will not be able to see it. This will only work if he's in standstill. You can compare that to text message reading. So with Sync 3, if you get a text message, you can show it on the screen. But you will only be able to view it if you're in standstill. You'll not be able to view it while you're moving. So this is very similar. Scrollable messages, usually what you do is you use a speak, you tell the user what you want to say, but you also use a scrollable message at the same time. Now, if you tell him audio via the speak command, he will still be able to understand what you want. If it's a scrollable message on the screen, he may not be able to read it while driving. And also, I forgot to say, if you guys have any questions at any point in time, I speak really quickly, but you can always interrupt me, raise your hand, and ask a question. I think.
While driving, is that when vehicle speed was zero? Like you stop at a stoplight or like in the car?
No, you stop at a stoplight. So vehicle speed, not even zero. I think it's less than 3, 4, something like that. So less than, whatever, 4 or something miles per hour. And then it will kick in. So this is all aligned. And this is the benefit of using a template-based system that OEMs control. This is all aligned with the general functionality of the Sync system. So if you're a Sync user and you're used to your text messages that you can't read when you're driving, this will work exact same way. Sorry, I didn't get that. Yes. Yeah. Okay. So the question is, does smart device link enforce the driver distraction laws, or is that responsibility of the OEM? This is the responsibility of the OEM. So in this case, Ford. In Toyota's case, Toyota or another OEM. Driver distraction guidelines is a quite complicated topic. It differentiates between the world. Different OEMs have different approaches regarding driver distraction. So smart devicing does not limit you in what you can do. So if you want to show a scrollable message while the customer is in motion, you can do that. Actually, in Europe, we do show scrollable messages while the vehicle is in motion. In the US, we don't. This is based on different driver distraction guidelines we have around the world, and an OEM can decide whatever they want when they're using Smart Device Link. And so your app will not be able to tell upfront if this is possible to show it or not. But because your users speak at the same time, you will still be able to inform. So speaks can always be sent, even if the vehicle is in motion. Does that answer the question? Yeah, so we do have best practices, and we have a talk about best practices later. The question is on developer.ford.com, do we have the information about what is to be used while driving and what is not to be used while driving? So we're going to have a session on best practices. We're going to talk about this a little bit. Developer.ford.com gives you more information on that. And generally, if you design your app based on the best practices we have, you will not have an issue. We, of course, don't give out guidelines to OEMs on how they should handle that if they implement Smart Device Link. A little agency called NHTSA is doing that, and they have guidelines that you can read up if you're an OEM and implement Smart Device Link. But for apps, we as Ford give out the guidelines, and we're currently in the process of migrating a lot of stuff over to smartdevicelink.com in the future so that apps have a one-stop of best practices on how to design an app. Yes? So you will be informed if the car is in motion or not. So you will always know if that is the case. So you can decide if you want to send a scrollable message or not. I would always, if you want to send a scrollable message, I would always accompany it by a speak so that you have the two items at the same time. So even if your customer is not able to see the message, he can hear the message. Currently, our system does not give the information to apps if somebody's in the front seat. No, there is no way of doing that generally. Seatbelt sensors is something we don't have currently in our open feature set of vehicle data for the app. So we're going to look into the vehicle data items a little bit later, so I would come back on that. So we have a whole session on vehicle data items, so we're going to go through all the different items that you can get, and we can have a look at that. So any other questions at this point? Yep. Sorry, I don't get it. Yeah, so the question was, not really a question, the correction was there's a call get belt status. Why I say we don't have that implemented is, and we're going to talk about this later in the vehicle data part, getting vehicle data items from different cars is pretty restricted based on what car you're connected to. So the percentage of cars that will get you belt status, and I think maybe my colleagues in the back can correct me, is pretty low at this point. So we don't encourage the usage of that. But let me take that back and talk about in the vehicle data part. So we're going to have a whole vehicle data session. We can talk about all these different things. Right? Other questions? More RPC calls. So user interaction. Now, we went from outputting stuff to the user to getting input from the user. Now, of course, you want to have information from the driver. So, for example, the driver has to choose a playlist to play. We do have two mechanisms that you go through when you want the driver to choose from a list. You have create interaction choice set, which is basically a way for you to create a list on the head unit. So before we can let the driver choose from a list, we have to know what the list is. Create interaction choice set will do that. Perform interaction then will perform the actual interaction. So the interaction choice set that you created before has a unique ID. That unique ID you feed into perform interaction, and the user and the driver then can select one of the items from the list. And then there are a couple of notifications for user interaction. There's on command, which will give the information that the user selected a command. So a couple of slides earlier, we had the add command request. This request will add one menu item to the menu. Now, the menu item just sits there and waits to be pressed. When the user comes in and presses that menu item, you will get an on-command notification so that then you can react on whatever it is that you want this button to do. And then we have on HMI status. We were talking about this a little bit earlier too. On HMI status will inform you about the status of your app in relation to the in-car HMI. So is it in the foreground? Is it in the background? Are you currently audible or are you not audible? For example, if the user listens to an incoming text message, your app will not be audible. Now, that may not be the best time to actually speak something or to actually play an important audio file. So you can pause your music playback while the user is listening to a text message, for example. Yep.
So in this case, where you get like on HMI status and like in the background, is you're not audible.
Yeah.
In the case where you say you have special permissions, you can send an alert. Is that still possible in an audible that you send emergency alert? I mean, somehow know, okay, you have some special permissions to send a background alert. It's too late if you're not audible, you're not audible.
The question is, when you're not audible, can you still send an alert? Or another RPC, I assume, that tries to get the attention of the driver? We do have different levels of alerts. So it is indeed possible to send an emergency alert over something that's happening on the head unit. Now, again, this usage is restricted from an OEM side, so not every OEM can just go and send emergency alerts, because I know app developers really well. They would all send emergency alerts for all their Spotify playlists and whatever else is going on. So this is restricted from the OEM side, but generally there is the possibility to have a higher grade of your alert than, for example, a current text message, incoming text message. But usually we speak about convenient features here. We speak about music and other use on their phone. There's not too many alerts going on usually that are of the category emergency on your phone. Requests for get vehicle data. That's the next part. We have vehicle data. There are two different ways to get vehicle data. You have get vehicle data that will give you one-time information about the vehicle data item. So let's say you want to get the speed, but only in this moment in time. You can send a get vehicle data request, and this will get you the vehicle data item at this point in time, and we have subscribed vehicle data. Now, if you're interested about the vehicle data in the long run, and you want to get informed every second about the RPM, for example, or about the GPS position of the car, you can use subscribed vehicle data. And subscribed vehicle data, you will request it, the response will just be, okay, you're now subscribed to the vehicle data item, and then you will get a notification that's called on vehicle data, which will give you the content of the vehicle data item every second. So get vehicle data, one-time request. The response will include the vehicle data item. Subscribe vehicle data, the response will not include the vehicle data item. It will just inform you that you're now subscribed, and then you will get on vehicle data items notification at the same time with the content. One note on all these slides, I just saw people taking pictures. You will also be able to get these slides after the presentations so that you can use them as a reference while you're hacking away and creating your apps. Very important, if you use a TDK, you need permissions. So getting vehicle data information is, of course, data that is owned by the customer. So we don't want you to just get that data without the customer's consent. So there is basically a two-step approach here. Your app has to request permissions from the for team. So we, in our backend, have to allow the app to actually get vehicle data items and also what vehicle data items. So it's not just you get vehicle data items, you can get whatever you want. There is a list of items and a functional grouping. So let's say you want to get location, then you can get the speed and the position of the car, stuff like that. This is enforced on the TDK too. So if you want to use the TDK, when you need permissions, talk to the for team. Now, because the data is owned by the customer, and this is very important for us, the integrity of this data is very important to us. We don't want to give it away to apps without the consent of the customer. So what we do is, when you start an app that has vehicle data permissions, you will get a pop-up on the car that says, hey, this app wants to get your position. Do you want to allow that? And the user will be able to say yes or no. Very similar to how it works on your iPhone. When an app wants to use your location, you get a pop-up, you say yes or no. Very similar situation on the car where the user can always say, I don't want to share my information. Now, in this case, your app should not crash. Your app should still be functional. If you have an app that solely relies on vehicle data and cannot work without vehicle data, you should inform the user that you need this vehicle data item and that he should activate it if he wants to use your app. So that is very important. Your user will always be able to not allow usage of vehicle data, because in the end, it's his data. Interaction with embedded systems. So relatively recently, we added a couple of new RPCs that work on the TDKs. And there are two big ones. First one is called send location. So let's say you have an app that is a point of interest finder, and you have all the best restaurants around. And now the user chooses a restaurant from your app. Now, he wants to go there. Up to now, it wasn't possible for you to actually go and send that to a navigation or something. Now, when your app uses the send location request, it can then take that point of interest into the embedded navigation. So how it works is basically you put in the send location request, you put the GPS coordinates of where you want to go. You give a couple of additional information like the name, some description to the point of interest, and you send off the send location request. On the head unit, there will be a pop-up saying, do you want to navigate to this position or to this point of interest? And the user will be able to hit start and then just go off and navigate there. So it's a really nice integration of apps with the embedded systems. The second one is dial number. And there's a little bit of a backstory to that. Usually you would say, hey, your app is on the phone, so it should be able to dial a number on the phone. This is true on Android. Usually on Android, you can just dial a number and the phone will go off and dial it. On iOS, as usually, stuff with Apple is a bit more complicated. So apps are not able to initiate a phone call if they are not in the foreground and active and the phone is not locked. Now, if the phone is locked or if your app is in the background, your app will not be able to initiate a phone call. For us as smart device link app link, we don't care if the app is in the background or if the phone is locked. You can still communicate with the head unit. So the best case scenario, of course, is your phone is locked away and stored in your center console, and you use the app from the head unit. Now, to dial a number, we introduced the dial number RPC. So what you do as an app developer is you call this, you put a number in there, you send it to sync, or the infotainment head unit, and the infotainment head unit will give you a pop-up asking the driver, hey, do you want to dial this number? And then the driver hits yes, and then the phone call gets initiated from the head unit with the benefit of being able to be initiated even if the phone is locked or if it's or if your app is not in the foreground, because we use the Bluetooth modes of initializing a phone call, just as if you would say, call my mom from your head unit. That is a bit of a tricky one, so if there are any questions to that, I can go explain some more. All right. So these are two items we added to interact with embedded systems. Again, permissions needed. So this is a disclaimer because send location and dial number are relatively intrusive RPCs. Stuff on the head unit happens. We don't want every app to be able to do this because let's say you have an app that dials a number, and the thing is that apps, if they send a dial number request, you will always get a pop-up on the head unit. Now, we don't want every app to just give pop-ups on the head unit at all times with dial number or send location. So there are permissions needed on the TDK for doing that. And if you want to do that on your hackathon, it's not a problem at all. Just let us know. We're going to add you to our backend, and you can then use these permissions and use these RPCs on the TDK. Another disclaimer to these send location and dial number RPCs is that the emulator we currently have does not support either of them at this point in time. So if you work with the emulator during the hackathon, when you want to do send location dial number, you got to move to a TDK and try it out there, and then you can move back to the emulator and keep on working on that. But the benefit is send location dial number are very easy RPCs. You just send them off, and then stuff happens. So if you test it and you send it off, the emulator doesn't show the UI, but if you send it, everything is fine. There is not too much interaction afterwards for your app. So the question is, can apps talk to each other and conclude each other's functionality? And just, yes. So we solved the problem of the app talking to the car. We did not yet solve the problem of apps talking to each other. So no, in short, no. Apps cannot talk to each other at this point in time. There's no app that does the dial number. At this point in time, we don't have a send location app out there, so we don't have a navigation app out there that is supported by AppLink. So we don't have apps talking to each other at this point in time.
So that means if I'm using a mobile navigation, I will not be able to direct that navigation app from my other app.
So I would put it in a multi-tiered approach maybe. So what you can do is you can use send location and try it out on the head unit and see if there's an embedded navigation. This is, of course, your preferred way of navigating. So you would do a send location. If you can't do it, you can maybe call an app directly on the phone. But again, this has multiple issues. For example, on iOS, you cannot call another app if you're in the background or if the screen is locked. So you can start a navigation that's on the phone. As soon as we're going to introduce mobile navigation, Dave showed it earlier in his keynote, as soon as we launch mobile navigation, we're working on getting send location to work not only with embedded navigation solutions, but also with the mobile navigation. But again, it will only work with apps that are integrated with mobile navigation. If your mobile navigation app is on your phone and doesn't have any connection to a smart device link, there will be no connection, no connectivity through smart device link with that app. Does that clarify that a little bit? The question is, how is the sandboxing done on the head unit? What is the security aspect on the head unit? We can talk in depth about this later. The short answer is, you don't upload any logic to the head unit. There's nothing to execute on the head unit. There's no logic running on the head unit. What you do is tell us what to show on the screen and give us lists. And the user chooses stuff from the list, and we inform you about that. So there's no logic going on. We still sandbox apps on the head unit, but there's no logic going on the head unit, and we can talk about this. Yes. So the question was then, the follow-up was, for example, images get stored on the head unit. Can other apps access these images? The short answer is no. Whenever you upload an image with your app, this app is the only one that can access it. Additionally to that, there's no way of getting stuff down from the head unit. So you can't get information from the head unit. When you upload an image, you can't download it again. That's not the idea of AppLink and smart devicing. The idea of AppLink smart devicing is if you want to show something, you upload it, and then you show it on the screen. But it's not like an extended storage for your app where you can just upload terabytes of data and then download it back later. So there's no way of downloading information that you uploaded previously from the head unit. At this point in time, so the question was, can you get the information of the current navigation destination from the embedded nav or mobile navigation into your app, right? Well, okay. So that's maybe two questions. So first of all, is there a way to get the navigation into your app? So the navigation destination into your app, or the old waypoints or old destinations that you had, can you get that into the app? The answer to that is at this point in time, no. But stay tuned on future improvements of the system. And then the other question was, can you get stuff from your app into the car, not only a destination, but maybe past destinations? The answer there is, you can set the next destination that you want to set from the app with send location. At this point in time, you can't set waypoints or older destinations into your car, but also there, stay tuned on what we're going to do in the future. So we are working, this part of the system is in active development where we try to integrate apps closer into the navigation system. Yes, please. That's correct.
Okay? The customer doesn't want to pay the extra money. Can they use a Google Maps as to get the destination, by Bluetooth audio and or integrated to the system?
So the question was, first the statement was that customers pay more money to get embedded navigation. That is correct. The question that followed that was, can they use Google Maps to navigate, and can these apps then communicate with the smart device link connected apps? So apps that are connected through smart device link can only communicate with the head unit, not with other apps, not through smart device link.
So can a person use Bluetooth audio and use the map on their handheld and the audio coming from the speakers on the radio?
So the question was, can a user use Google Maps and use the audio that goes through Bluetooth audio from the car? The answer to that is yes. You can do that on any head unit that has hands-free profile. and we don't lock that out and we don't disallow it or something. So it's just the same as on every car that has hands-free profile. If you use Google Maps on your phone and you start a navigation route, the navigation commands will be played through the audio system in the car, but there will be no connection to the head unit itself. So you won't be able to see the map on the head unit. You won't be able to interact with Google Maps through the head unit. And again, what Dave showed earlier is the mobile navigation feature, which will enable apps maybe like Google Maps, like Waze, like Here, like all the other navigation maps providers to integrate with and show the maps on the head unit, and then basically have interaction through the head unit there too. Is that a little bit clear? Okay. No comment on that part. So the question is, are there multiple mobile navigation partners or apps? Okay, so you can have as many mobile navigation partners in the future as you want. If you have the apps on your phone. We did not announce any partnerships, part of mobile navigation for now. In the future, when you have an app on your phone that is enabled with Smart Device Link that uses mobile navigation, you can have a list of different mobile navigation apps there, and then you can select the one you like. Now, on Dave's presentation, there was an image of the screen, how it looks like. So you get a pop-up, you get the sync embedded navigation, and in our case, you get the antelope test app navigation. You could have 3, 4, 5 additional apps there, and you can select whichever app you like the most. So send location, we're currently working, at this point in time, it only interacts with the embedded navigation. In the future, we work on getting that for the mobile navigation too. The question was, do all navigation apps use the same template? Is that the right question? So navigation apps have a little bit more freedom than normal apps. Usually navigation apps want to stream a map. So there is a video stream included in mobile navigation. This is not possible for any other kind of app, only for navigation apps, and we enforce that. So only navigation apps will be able to stream a video. So basically it's a full screen content, so you can show your map on the screen. So the template really goes in the background. You have a couple of buttons on the screen, you have a menu button there, but it's not as templated as the standard approach to AppLink. In this presentation, fundamentals on AppLink, I only talk about AppLink for media and non-media apps, not for mobile navigation apps. We didn't release that yet, it's not in any car. It is just something that works on Smart Device Link, but not something that works in any sync AppLink functionality at this point in time. The question is, can I comment when it will be available? The answer is no. You know, OEMs like to do press releases, and they don't like me to talk about stuff that's not released, so we don't do that. Any other questions on mobile navigation? Also, I would like you to erase mobile navigation from your mind from now on, because this is, the presentation will only go on for media and non-media apps. We can talk about mobile navigation a lot after this talk, if you guys want to. There's a lot of information there, and probably we're going to have future developer conferences where we're going to have hours and hours of mobile navigation information, but at this point in time, we use media and non-media as our baseline. I know, Scott, do we want to do, with Scott in here? Do we want to do a break and go back here in like 15 minutes? I think it's probably a good idea. So I'm just going to executive order a break of 15 minutes so everybody can grab a drink and a coffee. And we're going to be back here at 11:05.